Hi, my name is Jethro. Thank you for joining me as I'm going to present to you my honors research in mineral trioxide aggregate or MTA. We did this project with my colleagues Brian and Sean, and we had the supervision of Dr. Yao and Dr. Bogan in endoptics. So let's begin. So our greatest enemy is actually bacteria, right? When decay happens, the bacteria infiltrates the pulp, and pulp necrosis occurs, causing periparcal pathology and pain if left untreated. A clinician's job is to remove the decay, shape, disinfect the pulp chamber, and then obturate it with an inert material to prevent reinfection. We currently use gutta perca with a sealer as our gold standard, but actually gutta perca is unable to bond with the dentine interface and thus fail to provide a hermetic seal within the root canal. Furthermore, gutta perca actually cannot conform to the complexities of a root canal system, and thus we are always in search of a new material. A promising orthogate material is actually mineral trioxide aggregate. It was created by Tornum Vitajet as a perforation repair material, but currently it has many uses in, in cases like epexification, resorption defect, or direct pulp capping. So the versatility of MTA actually boils down to its properties. First of all, it's extremely biocompatible. It supports the healing of periodontium, and many studies have actually showed cytokine stimulation, resulting in bone and cementum formation around the cement itself. Secondly, MTA is able to form a superior seal with dentine and cement at the interface. This happens because as MTA sets, it releases calcium ions that form an apatite layer with the free phosphate ions from dentine. This forms a superior seal incomparable to any current day material. Thirdly, as MTA sets, microscopic crystalline tags penetrate into dentine, and these crystals are extremely alkaline and they obliterate and entomb any surviving bacteria in the dentinal tubules. So what we actually are trying to find out is how these crystalline, how these crystals are actually affected when different irrigations are used, different irrigation protocols are used. So we first began by collecting single-rooted human teeth. We kept two aside for a pilot study, and the other 45 were divided into three groups. Sodium hypochlorite, EDTA, and H-mix, which is H-mix is actually EDTA with chlorhexidine. We prepared all the teeth to standardized size under copious irrigation with 4% sodium hypochlorite, and followed by the final irrigation as we mentioned, hypochlorite, EDTA, or H-mix. We then filled all the teeth with sodium fluorescein tag ProRoot MTA and left it to set at room temperature at 100% humidity. We then removed 5 teeth from each group at 2 weeks intervals, ending at 6 weeks. For the pilot study, we also similarly prepared the teeth and filled one tooth with sodium fluorescein tag MTA and the other with just sodium fluorescein in distilled water. We were just trying to see if there were any confounding factors, such as capillary action, that might occur with sodium fluorescein. When the teeth were taken out, we set them in acrylic and actually obtained 3 1mm sections using a precision diamond saw. So we got one from the apical, middle, and coronal thirds. The sections were then viewed under CLSM, and ImageJ software was used to enhance the picture with a fine edges and sharpen image tool. What we got is this beautiful picture that we measured the maximum penetration from the average maximum penetration of the buccolingual and mesodistal direction. We also measured area penetration as a percentage, and it is the area penetrated over the total area less the canal space. We then used ANOVA and Koskowallis statistical analysis for the intergroup comparison and found that there was no difference between each group at each time interval, between each group throughout the experiment, so regardless of time as a variable, and between each time interval for each section from each group. So that means between each interval, specific time, 2 weeks, 4 weeks, 6 weeks, at the coronal, middle, and apical section for each group. There's no difference. None of them showed any difference. And in the pilot study, we noticed only penetration where MTA was used. So we deemed that actually sodium fluorescein was a suitable surrogate marker for MTA. So now the question is, why does MTA, or why is MTA still able to penetrate with the same efficiency despite the final irrigation protocol? we need to first understand the concept of smear layer. So smear layer is dentinoma that blocks the dentinal tubules, and it happens during the preparation of the canal walls. It contains organic and inorganic debris, and thus we use an organic and inorganic solvent to remove the smear layer, expose the patent dentine tubules. And the current school of thought seems to suggest that the removal of this smear layer supports ciliary penetration, improves seal, and marginal leakage. However, there's actually no study that supports its clinical efficacy, and in fact, a 2011 meta-analysis study showed that EDTA had no significant improvement in the success of primary endodontic treatment. Other studies have also suggested and shown that the removal of smear layer only led to an increase in microleakage when MTA was used. So, should we continue to use EDTA, or should we continue to remove the smear layer? Well, our study actually concluded that regardless of what final irrigation protocol we use, the penetration of MTA was not affected. And so why? An interesting study in ArtMed in 2012 showed that when MTA and other calcium silicate cement set, it forms a highly mineralized surface between the dentine. They call it, and they termed it, the mineral infiltration zone. That's very similar to the hybrid layer between dentine and primer. The zone is of a high pH due to the release of calcium hydroxide ions as MTA sets, causing a localized alkaline or proteolytic effect to the surrounding collagen components of dentine. This facilitates the transfer of ions between intertubular. This facilitates the transfer of ions to allow intertubular mineralization. So it should be noted that this form of mineralization actually differs from tubular diffusion and occurs regardless of tubular patency. To conclude this presentation and to look into further research onto how MTA's penetration is affected, we need to repeat this experiment with a larger sample size to try to reduce the random error resulting from clinical study models. This is to improve our study and make it more robust, make the results more robust. We also should have screened the teeth for the butterfly effect. So Russell and colleagues have suggested that in teeth that showed this butterfly effect, ciliary penetration in the buccolingual direction is consistently greater than in the mesial-distal direction. This provides a possible confounding factor in the study of ciliary penetration. And furthermore, to appreciate the crystalline formation in tubules, we should observe its maturation with SEM at different depths and times. And in conclusion, our study has shown that the use of a chelating agent for smear layer removal prior to obturation with MTA might not be as beneficial as we thought. If there are any questions, please feel free to drop us an email, and I'd like to thank you for your time.